students. So let us start fourth chapter in first year intermediate, that is Newton's laws of motion. Okay, right. So in this chapter, in MSET around you'll be getting 2 marks, and in NEET around I think 10 to 12 marks in NEET examination. Okay. So let us discuss about Newton's laws of motion in this. That is first law. So what is first law of Newton? See, every body continues from the state of rest unless and until external force is acted upon it. That means in this universe, if you take any body, see, unless and until an external force, this is called as external, not internal. Unless and until an external force is acted upon any body. This is weight of the body and this is reaction, normal reaction. In this chapter, I will be not discussing about any friction because friction chapter is again separate chapter. So here we won't discuss any points regarding friction. Without friction only we will be discussing all the points. So unless and until external force is acted, this body will remain in the state of rest or state of uniform motion along a straight line. That is called as Newton's first law. Every body continues from the state of rest or state of uniform motion along a straight line unless and until an external force is acted upon it. And it is applicable for any body in the universe. Okay? Right. And one more thing regarding the first law. First law is mainly telling about inertia. First law is mainly indicating about inertia. Inertia means again it's a property of a body due to which it remains in the state of rest or state of uniform motion along a straight line. Inertia is again of 3 types. Okay? One is inertia of rest, inertia of motion and inertia of direction. All these you can experience in the natural life. That is inertia of rest. How can you tell inertia of rest? Suppose a bus is about to start. The passengers are inside the bus. If the bus is about to start in forward direction, people will be going in backward direction when the first gear is given. That is inertia of rest. The same inertia of motion. Same bus when it is moving in forward direction, suddenly when brakes are applied, the people will be falling in front direction, forward direction. That is due to inertia of motion. Same thing, inertia of direction. If the same bus is making a rotation, right turn or left turn. If it is making a right turn, the body will be going in opposite direction. If it is making a left turn, the body will go in opposite direction of the turning body. Because this is due to inertia of direction. This all you can experience in the nature. Okay? So this mainly indicates about the inertia of the body, the first law of Newton. Okay? That means when the net force is 0, in other words, when F net is equal to 0, that means when no external force is acting upon the body will be at either rest or in uniform motion. Now let us go to second law, very famous second law. Okay? Now what is second law of Newton? See, this is very famous, that is F is equal to m into a. That means force is equal to mass into acceleration. So what is the second law statement actually? See, the rate of change of momentum, of a body is directly proportional to external force. That means you can write in this fashion: delta P by delta T. Delta P by delta T can be also written as directly proportional to F external. Okay? That means delta P means what? Change in momentum. P2 minus P1. And delta T means change in time. T2 minus T1. Sometimes this is also called average force. Sometimes this F is also called as average force. Okay? So that is given by some constant, removing the proportionality, into delta P, that is mv minus mu by T. So if you extend this formula, F is equal to K into m into V minus u by T. But if you know what is V minus u by T, it is nothing but acceleration. So finally, F is equal to K into M into A, or F is equal to M into A. So this is the derivation also I have given for you. F is equal to M into the rate of change of momentum directly proportional to external force, or F average can be also written as K into mv minus m, because change in momentum, final momentum minus initial momentum by time. Okay, so finally we got an equation F is equal to ma. So this is famous law, that is second law of Newton. F is equal to m into a. Now what does mainly indicate second law? It is telling about the force mainly. See, it is telling about the force, that is magnitude of force. That means rate of change of momentum directly proportional external. That means how much external force, more change in momentum, less force, less change in momentum. So it is defining about the force. Okay. Now let us learn about some more terms in second law. See here. F is equal to m into. Let us write some units for this one. For example, CGS first of all. CGS, centimeter gram second units. How to write CGS? Mass unit is grams. Acceleration centimeter per second square. So this is equal to F. But 1 gram into centimeter per second square is equal to 1 dyne. So generally we say dyne is the CGS unit of force. In the same way, MKS unit. In the same way, let us say the MKS unit here. What is MKS unit here? So F is equal to M, mass, kilogram, acceleration meter per second square. But we know 1 kg meter per second square is equal to 1 Newton. So here Newton is the SI unit of the force and dyne is the CGS unit of force. And already in first chapter, units and dimension, I have told you the relation also. 1 Newton is equal to 10 to the power of 5 dynes. I have derived also by using dimension analysis. Now we will define what is 1 Newton and what is 1 dyne, because these are very important IP examinations and also sometimes in some entrance examinations. So let us see what is 1 Newton. See, from this frame you can see what is 1 Newton. When you can say it is 1 Newton, when the body mass is 1 kg, when acceleration is 1 meter per second square. That means 1 Newton is that force acting on a body having a mass of 1 kilogram, producing an acceleration of 1 meter per second square. That is the definition of 1 Newton. I am repeating, 1 Newton is that force acting on a body having a mass of 1 kilogram, producing an acceleration of 1 meter per second square. In the same fashion, you can also define 1 dyne. Just now given what is 1 dyne? 1 dyne I can write as 1 gram into 1 centimeter per second square. So 1 dyne is that force acting on a body having a mass of 1 gram, producing an acceleration of 1 centimeter per second square. This is how you can define 1 Newton and 1 dyne. Clear? Right. Now, this is how you can define the second law of Newton and also some important tips regarding second law, that is F is equal to MA units regarding CGS and also SI unit. Okay. So just now we have studied about Newton's first law of motion, okay, and also second law. Now by using this second law, how you can apply it? Okay, by using second law, where you can apply second law? Okay, so generally second law you can apply in various things, like firstly the thing is outward motion, very important. See, outward motion you will be studying in intermediate IP. It is a derivation of 4 marks. Outward motion means very simple. See, here a pulley will be there. For that pulley, 2 bodies will be attached, namely M1, M2. Let this body be M1, this M2. So this is a pulley. It is fixed at a point O. And same string, see, same string, ఒకటే string అనమాట. Same string, 2 bodies are attached, M1, M2. Here you can apply anyway. Either you can take M2 greater than M1 or m1 greater than m2. If suppose m2 is greater than m1, then this body will come down and this body will go up. If m1 is greater than m1 will come down, m2 will go up. First, how to solve such type of problems? That is outward mission. Firstly, I will take normal method, IP method. Secondly, I will take MSET method. Short trick. That means in less time, how to solve the problem. So first, let us go in intermediate method, IP method. See, in IP method, what you will do generally, first you will be observing the forces acting on this body. Because this body is greater mass, this body will coming down according to our given. And this body will going in upward direction. That means this body will have an acceleration downward direction and this body will be having acceleration upward direction. This body will be having acceleration downward direction and this body will upward direction. And let us solve for tension also. See, here what happened? M2G, weight acting downwards. Since same string is there, tension is also same, upward direction, acting here, and here also tension, T. Now, let us solve for this one by using Newton's second law. Now, because M2 is greater, this body will come down. Let us apply the things here, free body diagram. This is M2, M2G, tension, upward. Because the body is coming downward direction with an acceleration A, for this if you apply first equation, that is M2G minus tension is equal to Newton's second law, that is M into A, M2 into A, equation 1. In the same way apply for this one, this body is going in upward direction. So upward means here apply the free body diagram, this is M1, upward direction T1, weight M1G, it is going in upward direction with acceleration. So if you apply here upward direction, that means T minus M1G is equal to your Newton's second law, equation 2. Now solve these two equations by adding. When you add, these two will be cancelled. See here, common what? G you can take, and here M2 minus M1, and here because you are adding, here you can take common M1 plus M2. So finally what you got? Acceleration G into M2 minus M1 by M1 plus M2. So this is how in normal intermediate method you will be getting acceleration. And if you take this equation and put in above equation, you will be getting tension also. Any equation, either 1 and 2, you will get tension. This is the acceleration formula. But I will give you in a simple method. Let us copy that one. Copy. Right. In normal method, that means MSET method, because that much time you will be not having in MSET. So MSET method I will tell you, simple method. How to calculate acceleration. See, in MSET, trick. Simple method, that is how to calculate acceleration and also tension. So see here, how to get acceleration and how to get tension. So here the simple trick is A net is equal to F net by M net. This is a simple trick. Because these two bodies are attached with the same string, both will have same tension and of course acceleration, same acceleration. One is downward, another is upward direction. So what is A net here? A net formula, simple trick is F net. What is F net here? Which force is larger? Because M2 is greater than M1. Therefore this force is larger. So F net means this force, downward force minus upward force. What is downward force? M2G minus what is upward force? M1G by M net. What is M net? That means total mass M1 plus M2. So అయిపోయింది కదా ఈజీగా. So finally what you got? A net is equal to G common M2 minus M1 by M1 plus M2. You can check the before formula. In intermediate method I derived by using so much of time, but in simple method you can get acceleration is equal to F net by M net. A net is equal to, that is F net means which is larger force, that force minus smaller force by M net. M net means total mass of the body. In the same way you can get tension also. Okay, tension formula. 2 m1 m2 by m1 plus m2 into g. Okay, 2 m1 m2 by m1 plus m2 into g is acceleration due to gravity 9.8. m1 m2 are the masses given and remaining all are derived by putting in the equations. So 2 m1 m2 by m1 plus m2 into g is the tension in the string, and acceleration is g into m2 minus m1 by m1 plus m2. So you can apply this formula anywhere. This is always right, anywhere, because we will be solving now various problems in different cases. You can apply the simple formula techniques. A net is equal to F net by M net, and thereby tension also 2 m1 m2 by m1 by m1 plus m2 into g. Okay, please note down. Right. Now let us go further now. After learning about Hartwood machine and shortcut for MSET, let us do some more numericals regarding this. Okay. Some more numericals means, for example, say, you can take some values now. For example, this is the pulley. You can take values, some values, your own values. Okay. You can take this one as 4 kgs. You can take this one as 2 kgs. Okay. As usual, tension always upward direction. Because this body is greater, its acceleration will be downward, and this one is smaller, upward direction. Now I told you just now, what is the formula? A net is equal to F net by M net. So what is acceleration? A net. F net. Ever peddadu indulo 4 kg is greater. So what is the weight acting? 4g. 4g means 4 into 10. Take g value as 10 meters per second square. So mg means 4 into 10, 40 newtons minus 2g, that is 20 newtons, 2g by m net, m1 plus m2, 4 plus 2, that is how much? 6. So what is A net? 40 minus 20, 20 by 6. 2 tens are 2 3s, that is 3.33, nearly, roughly. 3 3s are 9, 1, 3.33 meter per second square. So this is the A net acceleration. That means this body will come downward direction with how much? 3.33. Because it is downward, you can take it as negative sign. In upward direction, you can take it as positive sign. So this block will come down with how much acceleration? 3.33. 3.33 downward direction. And this block will be going in upward direction how much? 3.33 plus, and this is minus. Downward is minus, upward is plus. Like this you can solve. In the same way you can get tension also. What is tension formula here? 2 m1 m2 by m1 plus m2 into g, that is 2 into m1 m2, that is 2 into, what is m1? 2 kgs. What is m2? 4 kgs by m1 plus m2, 4 plus 2, 6 into g, you can take value 10. So 2 1s are, 2 3s are, 4 2s are 8, 8 into 10, 80 by 3. So you can solve this one. How much? 3 2s are 6. Okay. 3 6s are 18. 2.66. That means 26.66 newtons is the tension acting on the string. Like this you can solve any problem by using this simple MSET trick method. You need not go for long process, equation 1, equation 2, solving, adding and subtracting, putting again. Directly you can go like this. A net, F net by M net. Clear? Right. Let us go for one more. So like this you can solve the numericals by using Newton's second law. Clear? Now by taking the example of Hartwood machine, okay, with that we can solve many complicated problems by using simple methods. Just now I have given a trick. A net is equal to F net by M net. Clear? Right. Now one last problem to understand in a better manner. Sometimes they may be giving an inclined plane. For example, till now you have learned about normally. Or sometimes they may be giving connected bodies also. Connected bodies also you can calculate. That means one body, second body, third body, they will be connected with the string. For that also you can apply with the same formula. Nothing wrong in that one. Okay. Now let us go second one. Inclined plane. For example, this is an inclined plane. Okay. One pulley is there. Okay. Now for example, one body is resting here. Another body is here resting. Let the body masses be same masses, M and M. Let us assume. So here you know same string is there, but therefore tension will be same. Okay, because same string, tension will be same. And here angles are given. Let this one is 37 degrees and this one is 53 degrees. Now here he will be asking you what is A and what is T. Very easy. Just apply my method, simple method, you can get the values. Now before applying here, the thing is both are having same masses. So which is greater? So for that, first of all you have to solve the angles. I told you many times, famous triangle. 37. 37 means 3, 4, 5. The same way 53 means 53, 4, 3, 5. From this, first of all, you will get a sine angle because here you will have components. Okay, you will be having components here. You can see normal force, components. So this force is called mg sine theta. Mg sine theta. That means mg sine 37. The same way here also you will be having component mg sine 53 degrees. Okay, and this is your normal force. So first what you have to do is first solve the components. So first whichever force is greater, how to know? By the angle. So first one I will calculate this one mg sine 37. See from here, what is sine 37? Opposite by hypotenuse. 3 by 5. That is mg into opposite by hypotenuse. That is 3 by 5. Okay, that means how much? 3 mg by 5. This is the force pulling in this direction and tension in that direction. Okay. Now for example, this one, second block, what is the force? mg sine 53. From this, what is sine? Opposite by 5. That is 4 by 5. 4 by 5. That is 4 mg by 5. Now mathematically, which is greater? Both the denominators are same, 5 and 5. So this is 3 mg, this is 4 mg. So certainly this is greater, this force. Therefore, you can apply now A net is equal to F net by M net. So which force is that? This force is larger now. See here, 4 mg by 5. Okay, this force mg sine 53 minus this force. Okay, that is 3 mg by 5. This force minus this force is equal to what? F net by M net. What is total mass? M1 plus M2. That is 2m. Therefore, on the top 4 mg LCM is 5. 4 mg minus 3 mg how much? mg by కింద ఎంత ఉంది మనకి ఇంకా 2m ఉంది. m get cancelled. That is g by 5 to z 10. So for example, if you take g value is 10 meter per second square. Now what will be A net? If you are taking as 10 meter per second square, what is the value now? 10 by 10. So 1 meter per second square. So A net, common acceleration. That means this body is coming down with how much? 1 meter per second square, and this body will be going up how much? With 1 meter per second square. Now if you want tension also, you can calculate by using your mathematical equations. Okay, see here. You can put in any one equation, you can get tension value. Suppose if you want tension value, you can put in this equation or in this equation, you get same value. So this, because this body is larger force, it is coming down, it is pulling upward. Therefore, here if you apply this equation, T minus downward force mg sine 37, okay, mg sine 37 is equal to ma. In the acceleration ఎంత వచ్చింది మనకి? How much we got? 1, I think, isn't it? 10 by 10, 1 we got. So m into comma. So T is equal to m into g. If you take value as 10, sine 37, opposite by hypotenuse. Okay, opposite by hypotenuse. That is C, 3 by 5 is equal to m into 1. So 5 2s are, that is T is equal to 3 to the 6. 6m is equal to how much? Here m. Okay, na? Here minus is there, please. T minus. Okay, so T is equal to, take this 6 to this side. 6m plus m, how much? 7m. So 7m is the tension acting on the string. So this is how we will be solving the numericals for such type of problem, that is inclined plane. Okay, so like this you can solve any problem by using this trick, that is A net is equal to F net by M net. This is a very simple technique. You can apply for any number of bodies, inclined plane, plane surface, etc. etc. Okay, now let us see about, by using second law of Newton, lift problems. See, generally lift concept, in other words. So generally you can observe in lift, for example, see first case. Suppose lift is at rest position. When lift is at rest position, what are the components acting? W is equal to mg, and reaction will be upward direction. No movement. Therefore, what is the resultant force? R minus mg is equal to 0. What is R? Equal to mg. That means, what does it implies? That means the reaction acting on me is in upward direction. How much? My own weight, that is mg, when it is at rest position. This is first case. Now same thing if I apply for when the lift is going in upward direction. When I apply for the second case, lift is going in upward direction with an axle. Then what are the components here? Its weight W downward, reaction upward. Because body is going in upward direction, you can apply R minus W is equal to again MA, or R is equal to mg plus ma, or R is equal to m into g plus a. So what does it mean? When any person or persons are going inside lift in upward direction, you will be feeling more weight. You can see here mg plus ma. The person feels apparently more weight, person traveling in lift in upward direction. Now let us go to the third case, downward direction. Third case, same lift when it is traveling in downward direction, the acceleration A. What are the components? Weight W, reaction R. So because it is coming downward direction, what happens? W minus R is equal to ma, or W minus ma is equal to R, or mg minus ma is equal to R, or m into g minus a is equal to R. So the reaction acting on the person inside the lift or persons will be, you will be feeling apparently weight loss, lesser weight, because mg minus ma when the lift is going in downward direction. Clear all of you? Note down. We will go to the last case now. Last case. Last case means here what happens is, suppose suddenly due to some technical defect, if the string of the lift is broken, okay, well then what happens to the person? Suppose here when the person is going in upward direction or downward direction, suddenly when the lift string breaks due to some technical defect, then what happens? See the reaction? R is equal to m into g minus a, downward direction. Suddenly if the lift strings break, it is equal to freely falling body. That means A is become equal to small g plus c. So therefore what happens? The reaction inside the person, inside lift, m into g minus a becomes equal to g. G minus g how much? 0. So 0 and time 0, what is the reaction? No reaction. When there is no reaction on the body, what happens? The body will be floating in the air. Because reaction is there, we are coming downwards or upward direction. So we will be floating in the air. There is no reaction. Okay? So this is the last case. Reaction is equal to 0. No reaction on the platform feet. So body will be floating in the air. So these are the main conditions regarding lift concept. That is going in upward direction, downward direction, and suddenly due to lift, a technical defect, if the lift string breaks, then what happens? There is no reaction. Reaction is equal to 0. The body will be, what happens? No reaction. Then it will be floating in the air, body. Okay? So these are the main things regarding Newton's second law of motion. After this one, this concept, we will be learning about different concept, that is Newton's third law, and also momentum, inclined body acting on the wall with some angle theta. Okay, all these will be discussing in the next concept. Right, in Newton's second law, let us discuss about another important, most important is impulse. Now what is impulse here? See, impulse is indicated I is equal to F into T. Larger force acting on a body for shorter period of time. That is, units also you can say newtons into second, SI unit or MKs, or dyne into seconds. So what is impulse generally? See, in general life you can observe the impulse. For example, you are playing cricket. A ball is thrown by the, some fellow, outside fellow or the fielder to the wicket keeper. When the ball is caught by the wicket keeper, the person will be pulling backside. Why he has to pull backside? He can keep like this. Because larger force is acting on the body, he may break the wrist of the person. So that's why he is pulling back, that means reducing the force, impulsive force. Okay? Therefore, impulse is equal to larger force acting for a shorter period. Same thing can have so many examples. When a person is making a long jump, he will be jumping on a sand, or a person jumping from a pole vault, he will be jumping on a cushion bed. All these are to reduce the impulsive force acting on the body. Larger force acting for a shorter period. This is also, you can derive from second law again. See, this is nothing but again second law. See, I is equal to F into T, and F and T, M into A into T. Again, it is nothing but Newton's second law. See here, I is equal to M into, what is A? V minus U by T into T. It can, what happen here? I is equal to mv minus mu. చూడండి వచ్చింది కదా, change in momentum again is nothing but impulse. Again, this is nothing but Newton's second law. Impulse is nothing but again Newton's second law. mv minus mu. Final momentum minus initial momentum. That is nothing but impulse. The unit SI unit is Newton second, MKs or SA, and CJs is dynes into second. Clear? Right. Now, same thing, sometimes he'll be asking in this way. For example, see, suppose this is a wall. This is a wall. Very, very important case, this one for observe. Suppose a body is hitting the wall, for example, say at an angle theta, with the momentum mv. With the momentum mv. Very, very important case. Suppose a body is hitting, some ball having mass m with velocity v. It is hitting the wall at an angle theta. Now in this case, how to get the impulse? That is change in momentum. What will be the impulse? Change in momentum. For this, you can also derive also, or you have a general formula also. Let us derive for this one. For this, what I will do, I will extend this one line. I will extend this line, momentum mv. Now you can observe, this is the wall. Now if this angle is theta, I think this is also theta, vertical opposite angles theta. If this angle is theta, vertical opposite, this is also theta. Now this is the force coming down, mv, momentum. How much it is making angle with the y-axis, negative y-axis, theta. So let us solve the components. So what is the component here? mv adjacent by hypotenuse, that is because this side cos, mv cos theta, and in downward direction, that is j cap in vector form, minus negative y-axis. And what is this component? mv sin theta in this direction, that is positive x-axis, I cap. Okay, so these are the initial components because it is acting at an angle theta with the wall. So the momentum, that is one is mv sin theta I cap at positive x and minus mv cos theta in negative y direction, initial momentum. Because what is the impulse I am saying? Impulse, what is impulse? mv minus mu. And ఏంటి ఇక్కడ final momentum minus initial momentum. You have to calculate the momentum. Initial momentum is mu, final momentum is mv. So first you have to calculate what is initial momentum and what is final momentum. Initial momentum means it is hitting the wall. In what fashion? See, it is hitting with two components, two dimensionally. mv sin theta I and minus mv cos theta. Now, when the body is hitting with an angle theta, again it goes with an angle, same angle. This is theta, this is also theta. Again it reflects back. Okay? So when the body is hitting with some angle theta with the wall, same angle it is coming again outside. So again let us see the components this side. So if this is theta, again what are the components of this one? This is final one after reflecting. This is before and this is final. So what are the components for this one again? Again you can see mv cos theta, downward direction you can see negative. So minus j cap, this component again. What is this component? mv sin theta, which direction you can see na side వస్తుంది చూడండి, అంటే negative x axis, that means minus I cap. Observe carefully here, I am writing in vector form to get in proper way. So this one is this direction, minus mv cos theta j cap, and this is minus mv sin theta I cap. So now I will apply here final minus initial momentum. What is final momentum? Final means you can see here, these are the two values, final momentum mv, final momentum, see, final momentum. Okay, what are the values? Minus mv cos theta j cap, one component, and minus mv sin theta I cap. Observe carefully. Final one is minus mv cos theta j cap, downward, and minus mv sin theta. This is what actually? Final momentum minus initial momentum. What is initial momentum? Okay, one is this direction, one is other direction. So initial momentum means mv sin theta I cap, positive direction, and minus mv cos theta j cap, minus mv cos theta j cap. Now finally we will solve this one. Minus mv cos theta j cap minus mv sin theta I cap, take minus inside, minus mv sin theta I cap, minus into minus plus mv cos theta j cap. Now see, minus mv cos theta j cap plus mv cos theta j cap, both get cancelled, adding. Now what is left over? You can see minus mv sin theta I cap minus mv sin theta I cap, 2 times. Therefore impulse resultant, impulse is equal to mv minus mv, how much? Minus minus, that means minus 2mv sin theta I cap. Very very important formula. Okay, minus 2mv sin theta I cap. This is the final momentum, final impulse, mv minus mu. That means when the ball is hitting the wall with an angle theta, then you have to go like this, minus mv Sine theta into I cap is the vector form. That means in negative, because the body is reflecting back. So that is a negative sign. M is mass of the body, V is the initial velocity, sine theta angle, I cap is the direction, negative x direction. Suppose you may ask me, sir, ఒకవేళ ఇక్కడ ఈ యాంగిల్ ఇస్తే అప్పుడు ఏం చేయాలి? Suppose now the angle is given with the wall. Suppose if the angle is given with, with this surface, like for example alpha, then simply 90 minus theta. Because this total angle is 90 degrees, 90 minus theta చేస్తే ఈ యాంగిల్ వచ్చేస్తుంది. ఒకవేళ దీంతో యాంగిల్ మీకు ఇస్తే ఆల్ఫా, అప్పుడు ఇక్కడ ఏం పెడతారు? ఇంపల్స్ I is equal to minus 2mv, ఈ ప్లేస్లో సైన్ ఆఫ్ 90 మైనస్ థీటా లేదా 90 మైనస్ ఆల్ఫా ఇంటూ ఐ క్యాప్. అయిపోయింది. minus 2mv. What is sin 90 minus theta? First quadrant, cos theta. Therefore, minus 2mv cos theta or alpha can apply into I cap. This is the formula. If the angle is given with this surface, alpha or theta, then it is minus 2mv cos alpha and I cap. If it is given with wall, the value is minus 2mv sin theta and I cap. These two are very, very important. Even MCET also, they are asking one question. You can apply directly the form. Because why I have derived is to understand in better manner in vector form. Okay. So these are the main things you will be learning in the Newton's second law. And the last concept I will be going for Newton's third law, rocket propulsions, etc. etc. Okay. So we will meet in the next part. That is part 2 of Newton's laws of motion. Okay. Right.